In this video, we're going to talk about polynomial inequalities. We're going to be able to solve polynomial inequalities, and we're going to solve rational inequalities. So our first couple of warm-up questions is, what would the solution be as an interval for x greater than or equal to 0 on the xy plane? What would you shade? So if you were asked to graph some function and you wanted to know where x is greater than or equal to 0 on the xy plane, you would draw the xy plane. Here is y, here is x, and greater than or equal to would have been this side of the graph. Similarly, if you were asked to find what is on the left side, or x less than 0 on the xy plane, again, here is y and here is x, you would shade on the left side. The difference between these two is that this one, number 1, will have a solid line, and number 2 will have a dashed line at the y-axis. If we wanted a solution where y is greater than 0, so here is y and here is x, I would be shading above the x-axis, and because this is strictly greater than, I would have a dashed line here at the x-axis. And similarly for this one, I would be shading below. So I'm just going to come over here, and I'm going to shade, here is y, here is x. I'm going to shade below, and because this is inclusive, I'm going to have a solid line here. So if you were asked to find a solution as an interval for the function f of x greater than 0, where f of x is this polynomial, what would this mean in terms of the graph? Well, since f of x is the same thing as y for us, then we're looking for where this polynomial is above, which is this one, or equal to the x-axis. So that's what we're going to be doing here, is we are going to be taking polynomials that we've learned to graph, or even if we haven't completely learned to graph them, this polynomial inequalities will help us graph it. We're going to find an equivalent inequality for p of x on one side and of the inequality and 0 on the other. So in other words, if I have a polynomial, it's not a function, I'm going to set it so that one side has 0 and the other side has the polynomial with the constants and the coefficient, or terms with x's and the variables in them. And then I'm going to factor using the quadratic or any other method. And the reason is because I am trying to find where this thing equals 0 and also where it's above or below. We're going to then use the solutions to divide the x-axis into intervals, and we're going to use what we call a sign, S-I-G-N chart, and test those points of intervals on the graph of the polynomial. And graphing is going to be easier that way, and then determine the intervals in which the inequality is satisfied. Write our solution as set builder or interval notation. So we're going to start with our first question here. And it's already factored. So if it's already factored, we are good to go. If it's not factored like b, we're going to have to factor it. So since this is already factored, I'm going to build a sign chart, S-I-G-N chart. And when I build a sign chart, what I do is I take each one of those factors, once it's factored, and I put them on the left side of my sign chart. Each one of my factors, when I set them equal to 0, will tell me how to break up my sign chart. So I have the first one produces x is equal to 0, this one produces x is equal to 3, and this one produces x is equal to -2. So I'm starting with the smallest number, which is -2. Here's where x is equal to -2. Here's where x is equal to 0, and here is where x is equal to 3. What I'm going to do now is I'm going to choose a number in this interval, which is from -infinity to -2, non-inclusive, a number between -2 and 0, a number between 0 and 3, and a number between 3 to infinity. And how I came up with those intervals is these are the places in which this is going to be equal to 0, because I said each one of the factors equal to 0, which means that's the location in which it is equal to 0. So even if this inequality was less than or equal to, rather than strictly less than, I still would break up the inequality like this with open parentheses, not closed brackets. So I'm going to choose something on the left side of -2, So let me choose x is equal to negative 3. Now what I'm going to do is I'm going to figure out what the sign of each one of these factors are, excuse me, without actually finding the value. So if I put negative 3 in here, this is going to produce a negative number. If I put negative 3 here, negative 3 minus 3 more is a negative number. And if I put in negative 3 here, I'll have negative 3 plus 2, which is a negative number. If I were to have multiplied those numbers together, I would have had a negative multiplied by negative multiplied by negative. I have an odd number of negatives. So this region is negative, which means we are below the x-axis. I'm going to put in a number here between negative 2 and 0. Let's put in negative 1, so x is equal to negative 1. Put a negative here, it'll be negative. If I put a negative here, it'll be negative. And if I put a negative here, it'll be positive. I should say negative 1. If I put negative 1 in each one of these, I'm going to get a negative, and a positive. So I have a negative multiplied by a negative, which is positive, multiplied by a positive, which is positive, which means we are above the x-axis. Now I'm going to choose a number in the interval between 0 and 3, so I'm going to choose 1. 1 is a good number, so x is equal to 1. When I put an x is equal to 1, I'm going to get a positive. This will be negative, and this will be positive. So positive, negative, and positive. Let me go over that again. If I put in 1 here, 1 is a positive number. 1 minus 3 is negative. 1 plus 2 is positive. So I have a positive multiplied by a negative multiplied by a positive. That gives me a negative, which is below. And I'm going to put in a positive something over here. So let's put in a positive 10. Balling out of control here with a positive 10. This is positive. 10 minus 3 is positive. 10 plus 2 is positive. So we're above. And this actually could help me graph it, and I'll talk about that in a minute. But I go back and I say, I want the interval in which we're less than 0, which means I want to be below the x-axis. So I want this region and this region. So my answer is the region that is below, which is this one, which is this, negative infinity to negative 2, and this region, which is this, union from 0 to 3. Now I said this can help us graph, and it absolutely can. So let me just do a quick sketch. So I still had to find my zeros, which I did, and all the zeros happen to be real numbers, so they are intercepts. So that was at negative 2, it was at 0, and it was at 3. The first region tells me I am below the x-axis, then above, then below, then above, which means my graph has to look something like this. So it does, the sign charts do help me graph. On the next example here, you can see that it is not set up with 0 on one side. I'm just going to erase this so that we can do the next question here. So I'm going to go ahead and bring everything to one side. I think I'm going to bring everything to the left and have the 0 on the right side of the inequality. So I have x squared. I'm going to subtract 5x from both sides, so that gives me negative x. 4x minus 5x is negative x. I'm going to subtract 9 from both sides, so I get negative 2 is greater than or equal to 0. Now I have to factor this, so I have x minus 2 and x plus 1 is greater than or equal to 0. This produces x is equal to 2. This produces x is equal to negative 1. So I'm going to come over here and build my sign chart. So x minus 2 is the first factor, x plus 2 is the first, or x plus 1 is the second factor. And when I build my sign chart, it is not important, by the way, how I order my factors. What's important is how I order my numbers. So the numbers I'm going to choose are negative 1 when x is equal to negative 1, because that is one of the zeros, and when x is equal to 2, and that is also another one of the zeros. So my interval is from negative infinity all the way up to negative 1, negative 1 to 2, and then 2 to infinity. So I'm going to choose a number on this region. So I'm going to choose x is equal to negative 4. If I put a negative 4 here, it'll be negative, and this will also be negative. So negative, negative, multiplied together is positive, so we are above. In this region, I'm going to choose x is equal to 0. And I always choose x is equal to 0 unless it is a factor. So I put in 0 and I get negative and I get positive. So negative, positive, negative below. And I'm going to choose something in this final one, so let's put in 100 because we're just balling out of control. So 100 minus 2 is positive, 100 plus 1 is positive, so this region is positive, positive, and so together, combined, multiplied together is positive, so this is above. Again, this can help us graph this. If I go at negative 1 and 2, above means I'm here, below means I'm here, above means I'm here, so we know this is the shape of the graph. But to answer the question is, where are we greater than or equal to 0? Well, I am above when I'm greater than. And the difference between A and B is that B has inclusive right here. So that means I'm going to go from negative infinity to negative 1 with the inclusive squared bracket, union between 2 and infinity. So this next question, again, I'm going to go left or I could go right. It doesn't matter. I like to have my leading coefficient positive, so let's go right with everything. So I have 0 is less than or equal to, and I'm going to subtract x cubed from both sides, so I get x cubed minus x cubed. Oh, actually, you know what? I'm going to go left again because indecision, it's awful. I have x cubed and x squared. Those aren't actually going to combine, so I'm going to go left. So I have x cubed minus 3x squared minus 9x plus 27 is less than or equal to 0. And I'm going to factor by grouping, so I'm going to factor out an x squared out of the first group, gives me x squared factors out, so I have x minus 3. Out of the second grouping, I'm going to factor out a negative 9, leaving me x minus 3, which is less than or equal to 0. And then I have x squared minus 9, x minus 3 is less than or equal to 0. I'm just going to erase this from earlier. So then I'm going to come up here, and the x squared minus 9 factors, so x minus 3, x plus 3, and then the x minus 3 that was already there. So I have x minus 3, the quantity squared, and x plus 3 is less than or equal to 0. All right. This produces x is equal to 3. This produces x is equal to negative 3. So let's go ahead and build my sign chart. X minus 3, the quantity squared, and x plus 2, or x plus 3. Now here I want to stop and take a moment and say, look, if this power is 2, then you better make sure on your sign chart you bring that power with you. If the power is 5, you better make sure you bring that power with you. Now, up until this point, I didn't have to worry about it because up until this point, the degree of each one of my factors was 1. Now I have a degree of 2. So I got to just make sure I bring that with me. Oops. So now I'm going to build my sign chart. And I have negative 3. X is equal to negative 3. Remember, we have to go from left to right. I have x is equal to 3. I have to go from left to right of our zeros, so we have to order our zeros. We don't have to order our factors. So our first interval is from negative infinity to negative 3, negative 3 to 3, and then 3 to infinity. And the great thing about this one being squared, no matter what I put in, when I square it, it's going to be positive. I love it when I see that, so I can just go positive, positive, positive. No work needs to be done. So what I have to do now is pay attention to what's going on here. So I'm going to put in, let me put in x is equal to negative 10. This will be a negative number. This region's negative, which means we are below. I put in some number in this next interval. Let's put in x is equal to 0. Like I said, I like to use 0. This is positive, this is positive, this is above. And I'm going to put in something over here. Let's do x is equal to 9. This is positive, this is positive, this is above. Again, this will help us graph. So our zeros were at negative 3 and positive 3. We start out below, then we above and above. So this tells me my graph, since they're above on both sides of the 0, that means this must touch the graph at that 0 and bounce back off. And knowing from our previous video is that we know that multiplicity is 2, it will touch and bounce. That confirms our graphing. And so we go back to what we're asked for. So let me go back over here. And what we're asked for back over here was that we're less than. The only region we are less than is in this region, and less than or equal to. So this is the only region. So it's from negative infinity to negative 3 inclusive, because it's less than or equal to. Okay. Now, find a polynomial inequality for this solution set. Well, we know from up above that each one of these numbers are a 0. If that's x is equal to negative 4 is a 0, and x is equal to 3 is a 0, and x is equal to 7 is a 0, that means what I have is I have x plus 4, x minus 3, and x minus 7. Now, we are trying to find out whether or not where this interval would be greater than or less than. So if I were to put this on a number line, that was terrible. So if I were to put this on a number line, here's negative 4, here's 3, and here's 7. So in this region and in this region, so I could have a graph that has a leading coefficient of 1. So I'm going to assume at all times in this video, we're going to assume a is either 1 or negative 1. So let's let it equal to 1. And it would have a graph that could look something like this. And so I could say, oh, I want it where it's greater than or equal to 0. Now, if I took this graph, or this polynomial inequality, and put a negative 1 there, then when I had x plus 4, x minus 3, and x minus 7, if I put this on a number line, again, from negative 4 to negative 3, and then 7, and this is my region, and this is my region. Say I wanted it to go like this. So if that's what I wanted, then I could have had less than or equal to 0. So either one of would have worked if I paid attention to where there's a positive 1 or a negative 1, and then looking for what I want. So again, these really do help us graph our polynomials. Erase that so I can do the last one. So on my last one, here I have got, I'm going to put this on a number line, and I have negative 3, I have negative 1 to 1, and I have 5. So I have this region, I have this region, and I have this region. So what I could have is a polynomial that looks like this. So this produces x plus 3. This one produces x plus 1. And this one produces x minus 1. And then lastly, this produces x minus 5. This is a polynomial of degree 4, so I want this thing greater than or equal to 0 if my leading coefficient is 1. Or I could have a negative 1 out front, x plus 3, x plus 1, x minus 1, x minus 5, less than or equal to 0. And then its graph would look like this. Here's negative 3, negative 1, 1, and 5. It'll look something like this. So that's it for this video. I guess we don't do polynomial or rational inequalities in this video, just the polynomial inequalities. If you have any questions, bring them to class. Otherwise, we will see you in class.